What's up, AP Chemistry? I wanted to spend some time going over a couple of the 1.4 problems. I know some of you had wanted some extra practice. Some of you had tried these a couple times. So I wanted to go over a couple of the ones to hopefully get you guys a better understanding of them. So here we go. For this first one, again, we have the 1.4 problems. It says a 1.90 gram vitamin B tablet is found to contain 0.0122 moles of niacinamide, a form of vitamin B3. It gives us the chemical formula, it gives us the molar mass, and it wants the mass percent of niacinamide in the tablet. Well, okay, here's how we're going to have to go through and solve this. Whenever we're thinking about this, mass percent in the tablet, that means I'm going to need grams of niacinamide, C6H6N2O, over the grams of the tablet. And since we're looking for a percent, I'm going to have to multiply this by 100. Now let's see which of these we actually have in the problem. A 1.90 gram tablet. Ooh, so that's my denominator. Is found to contain 0.0122 moles. Uh-oh. Well, for my numerator, I need grams of niacinamide. The problem gives me moles. So what I'm going to have to do is to take we'll write over here, 0.0122 moles and change that back into grams. Thankfully, they give us the molar mass. For every 1 mole of niacinamide, 122.13 grams of it. My moles cancel out, leaves me in grams. So I can get, looks like 1.49 grams of niacinamide. And that is my numerator. Sweet. And then according to the chemical formula, I'm going to have to multiply this by 100. And so once I put this into my calculator to get a percent, I should end up getting 78.4%. It does say it wants it to 3 significant figures, so there's my lovely 3. Cool. All right, now here's our second problem. Now we're talking about the amino acid glycine. This is a very similar problem to the one that we just saw. So if you got this one, here we go. A 1.60 gram tablet is found to contain 0.0133 moles of glycine. What's the mass percent of glycine in the tablet? Just like before, I'm going to need the grams of glycine divided by the grams total of the tablet times 100. So now as I go through here, let me see what I have. Okay, I read the problem again. 1.60 grams, that's my denominator. And then I need the grams for my numerator. Oh, they don't give me that. They give me moles. Aw. So now what I'm going to have to do is to change grams into moles. For every 1 mole, I'll get the molar mass on the periodic table. They were nice enough to give it to us. My moles cancel out. And then what I'm left with ends up being 0.998 grams of glycine, and that's my numerator. Sweet. So now with my chemical formula, I got my numerator, I got my denominator. I have to make sure to multiply this by 100, and then I end up getting whatever the answer is. Oh, my calculator died. Times 100. My calculator ends up giving me 62.375. But what does it say? It says using 3 significant figures. So I want to keep my first 3 places, keep these guys. After my 3 places, I notice a 7, so that means I'm going to bump up to 62.4%. And there's my answer there. Cool. For the last problem, this one's kind of tricky. This is like the different variation that we could have seen. For this problem, this is definitely more advanced. A student determines that a 9.8 gram mixture of magnesium chloride and sodium nitrate contains 0.050 moles of magnesium chloride. What's the mass percent of chlorine in the mixture? Okay, well, how are we going to solve this? Well, the mass percent of a substance can be determined by comparing the mass of the substance in the mixture to the total mass. Okay, so let me get that down. I'm looking for the mass percent of chlorine. So that means I'm going to need the grams of chlorine divided by the grams total of the mixture or of the tablet. And then since it's a percent right there, we multiply it by 100. Okay, so now I'm kind of set up. Now, which of these do I have in the problem? I have the grams of mixture. But what I don't have is up here at the top, the grams of chlorine. So we're going to have to find it. Now, what do they tell us? They tell us that I have 0.05 moles of MgCl2. Oh, that doesn't look good. I'm going to rewrite it. All right. Now, if I look at this, for every 1 mole of MgCl2, what am I looking for? I'm looking for my mass percent of chlorine. Oh, well, this is almost like a combustion problem. Remember when we were talking about water and how there's 2 hydrogens in it? We can apply that knowledge here. For every 1 MgCl2, there is 2 chlorines. Huh. Well, if I cancel that out, this would be in moles. What am I left with? 0.05 times 2. Maybe you can do this in your head. I'm just going to be extra safe. I'm left with 0.1 moles of Cl. Oh, so I can just put the 0.1 moles of Cl over into my formula? No, we got to watch out. It's looking for grams of chlorine. Do I have that? No, I got moles. So I'm going to need one last step. I'm going to take the 0.1 moles of Cl and say for every 1 mole of chlorine, I use my periodic table. There's 35.45 grams of it, and I end up getting 3.5 grams of chlorine. That's what goes in my numerator. So that's how we found it. It's tricky because there's more than one step. Now when I put this into my calculator, it doesn't give me a sig fig percent requirement, but if I look at my givens, here's 2 sig figs, here's 2 sig figs. So I'm going to go to 2 sig figs in my answer. We would get 36%. Cool. Hope that helps kind of seeing everything worked out. So yeah.